Alright, hi everyone. So this is the revision video for topic 6, which is series. Okay, so basically in this chapter you learn few series. So the first one is what we call as binomial series. Okay, so I guess this is the one that you guys should be much familiar with if you are taking IGCSE. So you learn this in your IG syllabus. So which I think most of you do not have a problem for this. So basically you just follow the what is that called, the formula given. So if let's say you have a plus b to the power of n. Okay, so remember for p1 all your n here is just positive integer. Okay, so meaning that we are just talking about like 1 2 3 4 5 and so on. So it will be after you expand, then it will give you a power n plus nc1 a n minus 1 b plus nc2 a n minus 2 b squared plus so on. Then you just continue this sequence and your last one should be b power n. Okay, so normally for this type of questions, the question will ask you to either expand your series, or after you expand the series, then you will put in another term, or just by using that term, or just by using the binomial series given, and they ask you to find out what is the coefficient in the specific term, meaning that they will ask you that what is the coefficient for x squared and so on. So this is like very standard questions in your P1 paper. Okay, so for the second part, we'll be focusing on two progression. So for the first one, you learn about arithmetic progression. Okay, arithmetic progression. So for the second part, we learn geometric progression. Okay, so normally we call it as AP and GP. So you have arithmetic and geometric. Okay, so let's try to introduce this with a simple definition first. So what is an arithmetic progression? So it's a progression that you have a common difference. Okay, so if you can recall, so common difference, which means that they should have the same constant for the difference between all the term. Meaning when you try to use T2 minus T1, it will be equal to your T3 minus T2. Okay, T here meaning the term. So when you use your second term to minus your first term, it should be the same thing when you use your third term to minus the second term, which means it will be always Tn plus 1 minus Tn will give you the common difference. Okay, so for geometric progression is about multiplication, or or sometimes it can be like division, but normally we just try to treat it as like a multiple. So if it's divide, then we will take it as a fraction. So for geometric progression, we have common ratio. Okay, so common ratio meaning when you try to use your second term to divide by your first term, it should be equal to when you use your third term to divide by your second term, meaning that with all Tn plus 1 over Tn will give you all the same answer, which is the common ratio. Okay, so let's try to look at some of the example for arithmetic progression. So we have two types here. So this is example. Alright, so the first one we are talking about when you have a positive d. Okay, so when your d is greater than 0. So for example, if let's say you have 1, 4, the common difference of 3. So if let's say 1, 4, 7, 10, 13, and so on, you can see the common difference here is actually positive 3, correct? So that's why for this one, you can see that the arithmetic progression here is actually an increasing one, correct? Then after that, you will have d lesser than 0, which means if let's say you have, for example, 10, then 8, 6, 4, 2, 0, -2, and so on. So you can see that the common difference here, when you use 8 to minus 10, you should be able to get a negative answer. So that's why for this term is a decreasing one. Okay, so meaning if you have common difference as positive one, you should get a number or get a series that is getting bigger and bigger up to infinity. So if it's lesser than 0, then it will give you a decreasing series, which will be going, the value will be lesser and lesser up to negative infinity as well. So for geometric progression, right, normally we'll try to treat it as like two parts. So the first part is as if you have r greater than 1, okay? Which means if let's say an easier one would be if r is 2, then meaning that you might have 2, 4, 8, 16. So you can see that the common ratio here is 2. So when you for you to get all the subsequent term, you actually multiply 2. So when you use 4 divided by 2, 8 divided by 4, you'll be able to get 2. So you can imagine that when you have this kind of uh series, right, it's actually an increasing one also, and it's actually getting bigger and bigger up to infinity, right? So this is the same thing also. It will be actually increasing up to infinity as well. So another part we have things like r lesser than r is lesser than -1. Okay, which means if let's say your r is -2, so you might have 2, -4, then after that 8, -16, and 32, and so on. You can see that the number here is actually getting bigger and bigger as well, but then it's just that your sign is like alternate. So the number will be going into infinity as well. So for these two series is actually what we call as divergent. Okay, so meaning that the numerical number is actually getting bigger and bigger. So that's another one which is special about the geometric progression is you have, if let's say your r is, the modulus r is between 1, so meaning your r is in between -1 or 1, which means it's a fraction. So if let's say you have this kind of ratio, which means for example if I give you like 10, okay, so if it's 1 over 5, then you'll be able to get 2, then after that 0.4, then after that 0.08. So how do you get every term? It's like multiply with 1 over 5, correct? Then this is the number that you get. So you can try to imagine that if let's say you continue for this term, right, you continue to list down all your term in the series, you'll be able to get a number that is getting lesser and lesser. But will the number going to be negative? No, right? It will be just approaching to be 0. So this is like a convergent series. So it's the same thing. If let's say I try to change it to -1 over 5, then I will have 10, -2, 0.4, and then -0.08, and so on. So you can see that although the number is like alternate between positive and negative, but the numerical value will be also approaching to 0. So this is the one that we say which is a convergent series. Okay, so later when we talk about the sum, and you will be seeing there's something special about this convergent series. Okay, so now let's talk about a simple one first. So the first one is the formula for the n term. Okay, so n term meaning if let's say you have a series of arithmetic progression, and if let's say you want to find the 100th term, then what is the formula that you should use? Okay, so your Tn will be equal to a plus n minus 1d. Okay, sorry, n minus 1 bracket d. Okay, so a is just your first term, meaning your T1, your first term. So n is the number that you want to find. So if let's say you want to find the 100th term, meaning you are going to put T100, so your n here will be 100. So the d is your common difference lah. So you must be very careful that it's either positive or negative, so you do not actually like miss that out. Alright, so the next part going to be the Tn for the geometric progression. So for this one is AR n minus 1. Okay, so it's power. So A, same thing, is your first term. R is the common ratio. So n is a number that is a number of terms that you actually want to determine. Okay, so the next one we have sum of first and term. Sum of first and term. Okay, so the difference between sum of first term and term is that term is for us to find a specific term. So for example, if let's say this is 1, then we call this as T1, T2, T3, T4, T5, meaning the first term, second term, third term, fourth term, fifth term, and so on. So sum of the first term, we are talking about a numerical sum. So meaning that if I am finding S5, meaning that is 1, 2, 3, 4, 5. The first five number I add them up together. What is that mean by S5? Okay, so it's the same thing. Just now we say 300, meaning that we are finding the 100th term. So if I'm writing S100, meaning I'm finding the sum of the first 100 term, meaning from the first term up to the 100th term, what is the total sum? So that's the idea. So the formula for the sum of the first term for arithmetic progression is n over 2, okay, and then 2a plus n minus 1d. Okay, or you have the other choices, which is by using n over 2a plus l. Okay, so I think you should be familiar with all this symbol here. It's just that the L here actually means that your last term. Okay, L here stand for your last term. But it's actually the same thing when you try to use this formula, because what is L is the term that you want to find, right? So L is actually a term, so meaning it's a Tn. So you imagine that when I try to change L to a plus n minus 1d, right, I actually get back to the exactly same thing. So this is how is that come from. So the L last term meaning, for example, if you are finding S100, that meaning your A is your first term and your L should be your 100th term. So you use your first term plus your 100th term and you multiply by n over 2, then you'll be able to get your answer. So for the geometric progression, you have sum of first term will be equal to a multiplied with a minus r power n over 1 minus r. Okay, I know that we have another formula which is by using rn minus 1 and then r minus 1. Then you will need to remember like r is positive or negative, right? But then in this video, we're trying to focusing on what is the formula that will be given in your exam, and this is the formula that will be given. Okay, so it's actually not in I mean it's not compulsory that you must find out what is like whether you must use which formula by determine whether your r is a positive or negative, but actually by using both formula it will just give you the same answer. So that's why for your convenience, then we just try to revise on the part that will be given in your exam, which is this. Okay, so no matter what is your r, as long as you are finding the sum of first and term, you can use this formula. Okay, so the last part, we are going to talk about the thing that just now I say something special about the convergence series for the geometric progression. So you don't have this part for arithmetic progression, because as you can see that for these two terms, when it's increasing or decreasing, is going to be approaching to your infinity. So you only have sum of infinity for GP only, and the ratio must be in between of negative 1 and 1 only. So this is for convergence series. Okay, so for all the convergence series, meaning in another words, your r should be in between negative 1 and 1, then you have a sum of infinity. Okay, which means the idea is that 10 to, then you continue. So you try to write the whole list until infinity, and what is the total sum of it. So this is what is that mean by sum of infinity. Okay, equal to a over 1 minus r. Okay, so a is your first term, then r is your common ratio. So this is the part for your AP. So some helpful tips for you in solving the question will be, for example, if let's say you are having an application questions, right? So what you can try to do is actually you need to write down your series, then it will be easier for you. So if let's say the question give you a scenario, so it will be good that you can write down the series first, then you check whether it's an AP or GP by using you check whether you have a common D or you have a common R. So this is something that can help you to actually identify which progression you are dealing with. So some of the other tips that will be helpful here is if let's say the question gives you a formula for Sn, okay? So meaning that this is in the case where they didn't give you what is your A, what is your D, or what is your R. They just give you a formula for the sum. Then how are you, then they ask you something like, how are you going to find the term? Okay? So some interesting facts that you might want to remember here is that the first term is actually the same thing with the sum of the first term, correct? So the idea is, if let's say I have one term like 2, 4, 6, 8, 10. So you can imagine that my first number and the sum of the first number, isn't it the same thing? So T1 will be equal to S1. So this is something that might be helpful. Then other than that, you also have, if let's say I want to find T5 and I only have the formula for Sn, then how am I going to do that? So you can imagine, if let's say I have 5 numbers, so T1, T2, T3, T4, and T5. Okay, so if I want to use the formula for Sn to actually help me to find the answer, what can I do? I can use the sum of the first 5 term to minus the sum of the first 4 term. Then what do I get? I get exactly what is the fifth term, correct? So that's why T5 is equal to S5 minus S4. Okay, so this is something that you can remember. So it's the same thing if let's say if you want to find T 29, then how? Then you are going to use S29 to minus S28. Okay, so I'm only speaking for the part where you are given a formula for S. Okay, so if let's say you have a progression, you know how to do, you do have your A, D, R, then of course you are going to use the formula just now to help you to do that. So if let's say same thing, you are given an you are given a expression of Tn, then after that they ask you to find the sum, then how are you going to do that? So the same thing, your A, so you know that for your sum, right, for you to actually create the formula, then you will need, for example, for your AP, then you will need your A and D, correct? So for a common ratio, you will need your A and R. So how do you actually find it? So your A is the same thing with T1. Okay, so meaning if let's say they give you Tn equals to 3 plus 7n, so meaning when you substitute your n with 1, then you'll be able to get your T1, which is basically your A lah. So if let's say you want to find your is an AP, and if let's say you want to find your common difference, so how do you find your common difference? It's by using T2 minus T1, right? Then you just substitute 2 inside, substitute 1 inside, then you minus, then you'll be able to get your D. So but if let's say it's an GP, that means that you will be able to get your R lah. So how do you find your R? Same thing, you get your T2, then divide by your T1, then you'll be able to get your R, then after that put it in the formula. Okay, but I think most of your questions is actually mostly about application, which they rarely ask this type of question where involving equation, but it can be. So this is like something that I mean a good reminder for you. So yeah, same thing, try to go through the questions, then after that try to understand like the logic behind the application. Actually it's quite easy that if you can get the series and get the variable or the constant that you need, then just by using all the formula that we mentioned here, and you should be able to get all your answer. Okay, so that's it for the part for series. Thank you.